The Fermi Paradox is one of the most profound and unsettling questions in modern science. If intelligent life is common in the universe, why have we not seen any evidence of it? The paradox is named after physicist Enrico Fermi, who in 1950 famously asked, "Where is everybody?" His question arose during a casual discussion about extraterrestrial civilizations, yet it highlights a deep contradiction between probability and observation. The observable universe contains hundreds of billions of galaxies, and each galaxy holds hundreds of billions of stars. The Milky Way alone contains perhaps 100 to 400 billion stars. Many of these stars are older than the Sun, and astronomical discoveries over the past few decades confirm that planets are common. Exoplanet surveys reveal that many stars host planetary systems, and a significant fraction of those planets lie within the habitable zone, where liquid water could exist. Given the immense number of potentially habitable worlds, it seems statistically plausible that life should have emerged elsewhere many times. To estimate the number of communicating civilizations, astronomer Frank Drake proposed the Drake equation in 1961. The equation multiplies factors such as the rate of star formation, the fraction of stars with planets, the number of habitable planets per system, the probability of life emerging, the probability of intelligence evolving, and the lifetime of technological civilizations. Although many parameters remain uncertain, even conservative estimates often suggest that numerous civilizations could exist in our galaxy. If intelligent civilizations are common, why do we see no evidence of them? This is the essence of the Fermi paradox. The galaxy is billions of years old. Even at sublight speeds, a technologically advanced civilization could colonize the Milky Way in tens of millions of years, a short timescale compared to cosmic history. If such expansion were typical, traces of alien activity might be visible through megastructures, modified stars, artificial signals, or probes, yet our telescopes and radio receivers detect silence. Several broad categories of solutions attempt to resolve this paradox. One possibility is that intelligent life is extremely rare. Perhaps while planets are common, the origin of life is extraordinarily unlikely. The transition from simple chemistry to self-replicating biology may require improbable conditions. Alternatively, microbial life might be widespread, but the evolution of complex multicellular organisms or intelligence could be exceedingly uncommon. In this view, humanity might be among the first, or even the only, technological civilization in the galaxy. Another explanation involves the Great Filter. The Great Filter is a hypothetical barrier that prevents life from advancing to interstellar capability. The filter could lie in our past or our future. If it lies in the past, then some steps such as abiogenesis, the development of eukaryotic cells, or the emergence of intelligence is extraordinarily rare. If the filter lies in the future, it may represent a self-destructive stage. Civilizations might commonly destroy themselves through nuclear war, environmental collapse, uncontrolled artificial intelligence, or other technological catastrophes before achieving interstellar expansion. A different class of solutions suggests that advanced civilizations exist but remain undetected. They may choose not to broadcast signals, following a policy of cosmic isolation. This idea is sometimes called the zoo hypothesis, in which humanity is intentionally left undisturbed, observed from afar like animals in a protected reserve. Alternatively, alien communication methods might be fundamentally different from our radio-based technology. They could use communication techniques beyond our current understanding, rendering our searches ineffective. Physical constraints also matter. Interstellar travel is extremely difficult due to vast distances and energy requirements. Even the nearest star is over 4 light-years away. Travel at sublight speeds would take years or centuries. Civilizations may find it impractical or unnecessary to expand physically. Instead, they might focus inward, developing virtual realities or sustainable planetary societies rather than galactic empires. Some scientists propose that evidence may exist but remains unnoticed. Our surveys of the sky, though advanced, cover only a small fraction of possible frequencies, locations, and signal types. The search for extraterrestrial intelligence continues to scan the heavens for artificial radio signals, laser pulses, or unusual astrophysical signatures. However, absence of evidence is not evidence of absence. Our observational window is limited both technologically and temporally. The Fermi paradox also intersects with evolutionary and sociological considerations. Intelligence is not necessarily a guaranteed outcome of evolution. On Earth, complex life existed for billions of years before humans appeared. Moreover, technological civilization has existed for only a tiny fraction of human history. It is possible that intelligent species typically do not survive long enough to overlap in time with others. Civilizations might arise, flourish briefly, and vanish, leaving only faint archaeological traces on distant worlds. In conclusion, the Fermi paradox highlights a tension between the vastness and age of the universe and the apparent absence of extraterrestrial contact. Given the enormous number of stars and potentially habitable planets, one might expect intelligent life to be widespread, yet we observe silence. Explanations range from the rarity of life and the existence of a great filter to technological limitations and deliberate isolation. Whether humanity is alone, early, or simply unable to detect others remains unknown. The paradox continues to inspire research in astronomy, biology, physics, and philosophy, reminding us that our understanding of life's place in the cosmos is still profoundly incomplete.
If you like the video, share it and don't forget to subscribe. Cosmic Secrets 108, turn on notifications. See you in the next video.